Hello, welcome to Team 1014 presentation. I'm Sena Park.
And I'm Hyungkwan Park.
And my name is James Hirons.
Our coach is Dr. Minchul Kang, and we're from Texas A&M University of Commerce. We're presenting our model regarding different content moderations for the 2021 SCUDEM 6 competition, and we completed problem C. Let's get started. Here is the brief introduction regarding our problem. Social media platform became an essential part of our modern public square. Anyone that have access to the internet can exchange and communicate information through these platforms. Social media platforms use various approaches or techniques to moderate contents posted on their systems, and the techniques change over time. Most often, they eliminate trolling or spamming, or they simply give warning notices to contents with hate speech or inaccurate information. It is very important to understand what exactly is happening when the social media platforms regulate the contents by using those kind of moderation. Platforms use different content moderations to regulate inappropriate contents on their systems. Our goal is to examine the role of two different moderation, censorship and warning notices. We'll be focusing on which technique is more effective and how the sharing of misinformation can be impacted by different moderations, and also we'll be looking at the movement of people between the groups and how the result can change when we modify variables and parameters. So, looking at our assumption, first, we assume that a single issue has divided people into two groups in a large population within a closed system. One is a misinformed group and the other is a well-informed group, and we assume that only two moderations exist, censorship and warning notice. We considered control parameters for our model, and when applying the moderations, movement only occur from misinformed group to the well-informed group. These are the variables within our model. We chose our independent variable as time based on weeks, and for our dependent variables, X stands for SNS news with false information, and Y for SNS news with correct information, and we chose M for misinformed SNS users, and then W for well-informed SNS users. We set up these variables in ratio. For the parameters, we chose KC for censorship rate, KW for warning rate. The news will be created from either misinformed group and well-informed group, so we chose KP for the news production rate. And since the news topic changes over time, we chose KD for news topic shift rate. And the news production rate KP should be greater than the news topic shift rate KD. And also we chose K1 and K2 for information perception rates, K1 for the movement of users from misinformed group to well-informed group, and K2 for the movement from well-informed group to misinformed group. Now let's look at our model. Misinformed users upload contents with false information, and well-informed users upload contents with correct information. The content with false information can be censored or it can be labeled with warning notice. And the movement of people between two groups can occur and it can be impacted by content moderations.
This was the base we decided to put. There are 50% censorship and 50% warning notice. 50% of false news will be censored and the other 50% of it will be labeled with warning notice. Therefore, false news will decrease and eventually disappear at some moment, and there will be more correct news flowing around. Misinformed users will be changed to well-informed users, and more correct news will be produced by increasing well-informed users. Let's analyze X. Since KC and KW are the same, as time progresses, there is half of outgoing news with the false information, which will be changed to correct news, and there is the other half which will disappear. The news with false information will be produced from the misinformed users, so as time passes by, the amount of false news will eventually decrease. For Y, there will be income from the well-informed users and false news. The outgoing news will disappear. Since the income is bigger than the outgoing news, the amount of true information will keep increasing. As KW and KC become bigger, we could see some changes in our graphs. We could examine a fact that as KC becomes bigger, curvature of XYWM got smaller. We kept on going on decreasing and increasing the value of KC and KW, and we got a final graph where it was near to a limit. We investigated that the platform only provides censoring, then no changes will be made. So that means only warning is effective. When the platform only provides warning, the reaction will occur faster. When the platform provides more warning than censorship, it is not as effective as before because some users may not even notice typical warning, or even if they did, they may ignore the notices. Moreover, most fake news doesn't get labeled to or float around unnoticed before moderators finally put a warning on the post. What if there was no warning? If there was no warning, the time for the graph to get to the steady state will increase, and this means that the graph's curvature will get smaller. By this, we can acknowledge that warnings are more sensitive than the censorship. As the news topic shift rate can be different, we tried changing the value. Surprisingly, when the rate increased, we could find out it took more time for this graph to get to a steady state. We could infer by the curvature that when KD is smaller, it is more sensitive. Intuitively, this will be correct. Since topics are shifting faster, there will be less time for the moderation techniques to take effect. It makes sense that the rates of transference would decrease since topics are changing quickly and it is difficult for the moderation to have any lasting effect.
We can see from these two graphs that if we decrease the value of X, or the percentage of false news, there isn't a much difference from the initial data of 50% and 50%. But when we observed an increased amount of false news, we can see that there is a change in curvature signs for the graphs. We can conclude from the difference of ratios of information, since false information have a bigger ratio than correct information, the amount of false information made will increase. However, as time passes, we found the graphs go back to how it should work. We can know that this will inform us that from time to time the ratio of correct information would be greater than false information. We can find out that the time is when the moderation took place. Next, we analyze the change in initial value for well and misinformed users. On the left, with a 70% misinformed to 30% well-informed, we can see that all of the values approach their steady states. However, there was a slight increase in the false news away from the steady state, but then it quickly approached its steady state. And then whenever we examined less misinformed users and more well-informed users, we noticed the delays from the steady state for both the well-informed users as well as the misinformed users, rather than the actual information itself. We also looked at another possible moderation technique, with user moderation such as a like and dislike button. With the like and dislike button, users can either vote in favor or against of content that they see. Users will believe news that has more likes than dislikes and share it more. It can act like a warning. We can notice from this that the equation will experience a change. Since the warning increased, we multiplied a ratio of well-informed users to express the graph. By drawing the graph, we found this form. We could see a change in the slopes at the start, but the moderation techniques quickly take place. Limitations and improvement. There are some practical limitations on this approach. Despite these efforts, people using the site may still fall into the trap of confirmation bias or simply become isolated within a network of like-minded individuals. At the same time, other people using the site adapt and make use of code words or other techniques to reduce the effectiveness of moderation techniques. A good way to improve our model would be to gather legitimate data from different social networking sites, like Facebook or Twitter, to better understand how the variables affect one another, as well as the rates of topic shifts in a regular information outlet. And I'm sure as you noticed, all of our graphs show that the steady state for correct news approaches 2. That is because the correct news differential equation used in our model is based off of a ratio, whereas everything else is based off of percentages. This was one limitation of our graph, and some modification to this differential equation model could have been helpful to approach a steady state closer to 1. As we can see, warnings are a more effective method of moderation than censorship. The warnings allow the news sources to correct their information, which leads to more immediate, accurate information from that outlet in the future. The higher the ratio of censorship to warnings, the lower the slope of increase for news with correct information. We can also see that as warnings increase, the time it takes to reduce the amount of misinformed users decreases, compared to the lengthy time it takes when censorship is the only method of moderation. These diagrams are based on equivalent amounts of warnings and censorship. Fortunately, the amount of misinformation, as well as the amount of misinformed users, does not seem to affect the rates of change from an even mixture of misinformed users and well-informed users, or correct or incorrect information, a substantial amount. Lastly, topic shift rate. The steady states remain the same, however, the ratio of topic shift rate to news production rate is inversely proportional to the rate of increase towards accurate news totality. Thank you for watching our presentation of SCUDEM 6 Problem C.